Okay. So any device in the network want to communicate need a ipv4. It's like a cell phone. You want to communicate, you need a cell phone number. No cell phone number, no communication. Same thing for a laptop, a PC, a printer. We need a IP. We need a unique identification. And we did say that the structure of an IPv4, we have 4 parts or 4 octets.
Shamat?
Yes, question?
Yeah, this is Gautier.
Yeah, Gautier, yes.
I want to ask about the protocol layers. So IP
No,
is in the
yeah.
is in the layer 3. All right, network.
Yes, yes.
Okay, so you said TCP has 4 layers and OC
Yes,
has 7 layers.
yes.
Yeah, but OC is the old one. Now
No,
it's
no,
TCP. Oh,
no,
you
no,
didn't
no,
say that.
no. So TCP was there before. So TCP was there
Okay.
before, and we decided to make it smaller because CCP is only 4, OSI it's 7. So say, okay, instead of making everything in big boxes, let us make them in smaller boxes. That's why we created the OSI. That's why the OSI is the most used for IP standard and all this
But
stuff.
in the net card, they didn't say that because I was reading that yesterday. They said people nowadays are using TCP.
Wait.
This is what they say in net card. So I was a little bit confused.
Okay, so TCP is still there. It's not like it's gone. It's still there.
Okay.
But when it comes to troubleshooting, we use the OSI. In fact, we are the same. We are the same, but let's say the newer version of TCP is OSI. That's why anything when we do, we compare them, you see. So we are both there. We still use, so from time to time in networking, you'll hear TCP IP, but we use mostly OSI.
Okay. Even in the company, they are using
Yes.
OSI.
In fact, even if you work in a company, you will never see that. It's only some advices, some rules to say, okay, Gautier, if you want to go to university, it's good for you to get a matric before, you see. It's some advices. But if you go in a company, you'll never see what is OSI, what is no. They say, okay, guys, if you want to troubleshoot a network, let us classify everything in groups, you see. So
Okay.
anything that's related to the media, wireless, the cabling, we're going to say, okay, all these things, they belong to the physical layer. Anything that belongs to the switch, that is managed by the switch, okay, we're going to classify them as layer 2. Anything related to the router, to IP, IPv4, IPv6, we're going to, so you see, it's only some advices, some guidance. You won't see physically that no.
It's like a software inside the router.
No, not so. It's only some advice, some guidance, and some principles. It's like if you want to go to US, you need a visa. You see.
Okay.
Yeah, it's some rules. It's some rules that you won't touch them.
It's like when we are doing troubleshooting, we start about knowing, you know, the the documentation.
Exactly.
Yeah, I understand.
Yeah, something like that. But thank you very much for your question, because your question helps to explain more
You're welcome.
and other students also to understand more. So thank you very much. By the way, I saw your profile picture. You sing very well, huh? Gautier.
Oh, thank you very
Yeah, you
much.
must make a DVD. You must make a DVD to get money.
Yeah, so I think I'm gonna be a guest during the graduation. So
Yeah. Yes, why not? Why not? Video of graduations.
Mr. Max?
If you have some ideas, yes, questions.
It's me, Ubuhle.
Yeah, Ubukle,
So
yes, yes.
I have not been in classes for long, but I'm gonna catch up soon because I've been having some kind of a problem. But I want to ask about the IP that we talking about. I just want
Yes,
to ask some question. So
yes.
the IP you mostly like is it the one that you find maybe in the router, and then like when you wanna set up the password for the router, and when you wanna know if the router is fast or quicker, is it that IP that makes you be able to access the router?
Okay, very good questions. So let me open my packet tracer. Especially you are in how do you call it, an ISP? Because I did work for ISP also, like telecom, but we call
Yeah.
it AT&T. So it's a telecom from America. They were everywhere. They are everywhere in any country.
Yeah.
And so I did work for them, so I do understand what you say. Okay, so for example, let's say you have a customer and you need to set up a Wi-Fi router.
Yes.
Uh, Let me check if here we have a Wi-Fi router. No, we remove it. Packet tracer, they keep on changing, updating. Okay, here there is no Wi-Fi router. Let me try click here. PCs, no. If I go to here, no. Now we remove the icon. I'm going to explain. I'm checking something. No, no, no. So let me allow someone to log in. What is it? What is? Yeah, yeah. Okay. My apologies if I don't pronounce your name properly. Yeah, I'm not used to, but yeah, Ubuhle. So it's good now.
No, it's fine, Mr. Max. You can call me B actually.
Yeah, B. Yeah.
Yeah.
Thank you very
B.
much. You'll get plus 1% for that.
Ah, okay, thank you.
Okay, so this is a router, and you are a user. You say, okay, you need to set up a router for a client. You need to set up a router for a client. I think we have a chapter for that where, so if your manager or someone says set up a wireless router, for example, or a router. So inside we have many fields. Mm. We have, so all this info will be given to you by the manager, or by the IT, how do you call it, architect, because it's them, we know the range and all this stuff. You need to set up the ipv4. Let me check if I can find a picture for you. Set up Wi-Fi router. I'm going to check if it is a picture image. So there are some inside. Okay, here we just show, yeah, this one, for example, yeah. Yeah, so this, for example, for T-Link, or what's that? TP-Link. There are many TP-Link or Cisco or U-Link, or there are many around, but the settings are almost the same. So you need a name. A name, for example, client Max. Where, in which region, South Africa, and what. So you see here on the left side, you have many stuff that you can click on it and configure. So normally your teacher, your manager will say, okay, this is a list of info you need to enter. Now, this router itself need a IP because you see here, anything that needs to go to the router, we need a IP. You see G000. We need an IP on here to allow all these guys to get connected to that IP to go wherever we want to go. So we can set up an IP on the interface. If I open my, if I type IP configure /on IP, so if they ask you job interview, what command are you going to type to view some properties on a network interface card? You say IP config base /all. Then I think I have a list of them, maybe 4 or 5 I'm going to send to you tonight. And you press enter. And you'll see all the adapters. It means all the, okay, the first one is my Windows info. Then anything, you'll see all the adapters, you see adapters or network interface card inside your laptop or your PC, any adapter. So this adapter is linked to Ethernet. It means your network cable. You see, Ethernet adapter. See, so if I'm using a network cable like I was using in the morning, I need, you see, this IP is mine for my PC. You see. Now, if you see default gateway, you see there is no default gateway here, it's blank. It means currently I'm not connected to a router with a network cable. So the default gateway, you see, G0000 is the default gateway of any people that is connected to that interface. So the default gateway is a physical interface on the router with an IP address that will allow all these guys to go out. So if I open this PC, in fact, it's a very good question. Me, I like questions because it helps to understand more. If I open this PC, I go to IP configuration. Any PC need at least an IP, like a cell phone, a subnet mask, like we did last time and we'll be doing again today. A IP will never come alone. It always comes with a subnet mask because it's the subnet mask that will identify this guy belongs to which room or which smaller room. So the subnet mask is very important. Now we need a default gateway, you see. Default gateway here is the IP of G0000. If you don't have default gateway, you cannot go to the internet. You see, if I remove this one let me copy. If I remove, and you want to go to the internet, you need a door to go out, gateway. If there is no door for you to get out of the classroom, you'll stay in the classroom. But if you put a door, then you can open the door and go out. You see, so the door for all these guys to go out is G0000, and it's also called default gateway. Sorry, this one is for another, this one is CCNA2 for other class. So don't check that. So when you have a router, you need always something called the default gateway, where everyone who wants to use your internet need to go through it, then they can go to the internet. So if I check my Wi-Fi, my Wi-Fi adapter, you see wireless LAN adapter Wi-Fi. Currently, I'm using Wi-Fi. I need an IP to go to the internet. No IP, no internet. This is my IP that is given to me by my router or by my ISP. Always, I have a subnet mask. See here, it's a default subnet mask. Now, I need a default gateway. You see this one? So this one is for my Wi-Fi router, my wireless router. My laptop needs to connect to this IP before going to the internet. DHCP server, and we'll check that later. It's a device that will automatically assign IP to you. Normally, it's configured in the router itself. So your manager will give you all the addresses. Then you go to each tab. You click on wireless. You check. You enter. You go to DHCP. you click. It's very simple, but we have a chapter for that. I think it's CCNA2. Yeah, CCNA2. I'm going to show you now. So I need a default gateway to go to the to go out. So this is normally what we need on the router. So if I want to change something in my router, I can copy this. Then I open a web browser. A web browser, a blank one, and I put that IP. It means what? I want to connect to that interface on my router. You press enter. You see, now this is my router. It's automatically asking me, who are you? Enter your password. I forgot that password. Okay, let me check if I have one. I think I have one.
Isn't it admin, sir?
Yeah,
With small
sometimes,
letters.
yeah,
It's
sometimes
admin.
it's admin. Yes, sometimes it's admin. It depends on the manufacturer. The manufacturer will say, okay. Yes, continue.
Oh, okay. So when you say we connect the router to the PC, now we're doing it as IT, like as are we doing it like when we're connecting the router to the PC? I don't know what is my question, sir, but do you hear what I'm trying to say?
Yeah, okay. Yes, no worries. So if you're in a company and everyone is using a network cable,
yes.
this is how it is. It means you have your PC, and like your PC at office, at the back, you have a network cable that is connected to a switch somewhere in your manager room.
Then a switch to a router. Okay,
to a
I
router.
get you. Sorry, I get it now. I get it where we are. Okay, I was a bit lost, but it's fine.
No worries. Feel free to ask questions.
Okay.
Because your question helps anyone else. So feel free to ask any questions. So I'm trying to check that password of mine. I put it somewhere. It starts with 8 something. 1 second, I'll find it. Code. Let me check code. Down. Yeah, I think it's this one. Let me try. So the manufacturer will give you that code. Let me try if it's that. Let me check. Incorrect password after one attempt. Your device will be locked for 1 minute. Okay. In fact, I need to check the label on your device for the password, you see. So normally it's given to you by okay, next time I'm going to check that. But if I go to CCNA2, yeah, and I go to PowerPoint, and I go to switch configuration, wireless concept, wireless LAN configuration. So when you go to CCNA2, we'll do an example then. So we have a chapter there called wireless configuration. So here, it's a demo. It's a demo, and you have a video where we explain everything in EtherCAD. And yeah, this guy is at home. And even if you have a Wi-Fi router at home, you can still use a network cable to connect at the back and connect to your PC. It's fine. Else you can remove it. And logging your, you see, most wireless routers are pre-configured to be connected to a network. So if you buy a Cisco or I don't know, any manufacturer, it's, let's say we have a basic settings there, like admin, and yourself, you go change whatever you want to do. Wireless router, default, you see IP address, default username, password, you see admin, normally it's admin, you see. Now yourself, you change basic network setup. Basic network setup includes logging to the router from a web browser. It's what I'm trying to do. But I'm going to check now. If you give me 1 minute, I'm going to take a picture and check. Now, when you log in, you need to change the default admin password. That is admin. Everyone knows that. You must change it and renew IP. So your manager will give you all this list because he knows that if you do correctly, the router, the user Wi-Fi router will get connected to a network properly. So yeah, there are a lot of stuff that we'll be doing at CCNA2, like the VAS wireless stuff. So this is something I wanted to show, but in EtherCAD it's much bigger. Let me go there quickly, chapter 13, to show you chapter 13. But this one, let me close. I'm going to chapter 13, CCNA. Let me come here. I log in. Okay. I was teaching CCNA2 to another class. That's why I'm here directly. So here, if you go to chapter 13, wireless LAN configuration. And you have a video, configure wireless network. You can check it's a nice demo here, very nice. So yeah, it's a nice demo. Continue, sir. So you see, he's trying to log on. Yeah. So now this is his router, his Cisco route. You must enter your username and password. Or sometimes we ask you password directly. She's going to do that. I'm going to log in. Now here, depending on the manufacturer, he can ask you, please change your password. So old password is admin. Then anything else, now you enter your normal password. You must use a strong password. Then it will show you the configuration page of the router. So now that you change your password, now you enter your password you created, then you need to log in. So when you're in, you see.
Mr. Mas, your screen is disappear.
My screen, okay, let me check. Oh, no, it's still there. Also,
we can see.
you see.
I think he must refresh his network, sir.
Yeah.
Because
please refresh.
Yeah, now I can see it now.
Okay, great. So you see here, so when you're inside, you have some tab, you see on your left side, status, networking, wireless, and all this stuff. So your manager will give you all the relevant info to enter properly. Then you go set up at the user home. Else, for example, for rain, when you purchase the router, they did the config already. So when you go, you grab your stuff, everything has been configured. If you have a client B, and you enter all your info there, and when you go, you buy and you plug and play. But if it's something, okay, anyway, you see, you can enter all this stuff. So this guy, there is a nice demo of how to set up a Wi-Fi router. You see, you can change some settings inside. But all these info are given by your ISP, Internet Service Provider. They know why they give you this IP. Yeah, it's static IP or dynamic. Yeah, so when we reach CCNA2, we'll be doing that. So for now, so Miss B, so for now, let's stop here for your question. But yeah, so we'll reach there. CCNA2 chapter 13.
All right, no problem, sir.
Okay, you're welcome. Now, guys, let's go to straight with this. So we did check that we have two groups of IPv4, public IP and private. So job interview. Remember, guys, this training we are doing is not a South African training. It's not a Mr. Max training. It's an American training. The same content anywhere in this world. Anywhere. So the same training that you get here, it's exactly the same. So please take it seriously, study well, and yeah, you'll be fine. If you put on your CV, I have CCNA, it opens doors. So you see, for example, in Pretoria, I was working for Cisco with my NETA card like you were doing, and I finished my CCNA, and AT&T was looking for someone, so in the same company. See, me, I did study CCNA visit. Okay, you study CCNA, come straight. So no interview, no what. But because my CV say I have CCNA, they know the content, they know all the chapters we teach at CCNA. So we know all the, okay, come. So now we're going to train you for 1 month on our product now. We don't need to teach you what is networking, what is default gateway. You see, you know all this already. That's great. Now come, we train you on our product so that you can help our clients. You see. So CCN is a very, very good one. It's international. It's international, very, very nice one. So yeah, let's continue. Job interview, you can ask you what's the difference between a public and private IP addresses. You see, you should know. I'm not going to repeat. I did send you this file. Now we have also three classes of IPv4, class A, B, and C. How to identify them? You know, we did. Now, as we said, we have public and private. So if we know the private, automatically we'll be knowing the public. So this is the range of private IP addresses. Miss B and Miss Grace, you too, this one, from now on, you should know them for you to get a promotion. We had one of our students, CCNP, when I started at CPUT. She was working for small ISP. After that, she went to another company. Then she went to Amazon. Now she works for Standard Bank, cloud computing. So she keep on growing, promotion. So it's very, very good, guys. So to start from this Cisco stuff.
Mr. Max,
Yes.
it's good here. So I don't know if you can just go back just a little to explain the private and the public IP address, how to defer that, the difference. So I know about the classes, class A, B, C, but I have just a little confusion to understand. So to make the difference between.
Okay, so quickly 1 minute because we need to finish IPv for today. So who can explain to Gautier? So someone please try to explain. I'll be back in 1 minute. So please explain to your friend.
Hello, Mr. Max. Hello? Hello?
Excuse
Hello?
himself. You can explain.
Oh, can you listen? Can you hear me? Yeah. Yes, the question Gautier is asking about the difference between the IP, private IP and the public. So the difference is about class A. About private, you will see there's 10,000. In class B, there's 172 and a 16 and 00. And then Class C in private, there's 192.168.00. So in public, the number, Mr. Max, can you put for public, please?
Public. No. So if you know private, if a IP for class A is not this range, automatically it's public.
Yeah.
Yeah.
So you can make a difference just when you saw those number, you know already this one are private, except those private one. So the rest one is public.
Yes. So if it's a class A, for example, this one, you see, it starts with 68 now. The class A. Is that only is that IP?
Automatically it's public.
Yeah, you see, because if it's a class A, to be a private IP for class A, it should start with 10. You see, but this one is not starting with 10, it's 68. Then it's not private. Then if it's not private, it automatically public. Okay, so you have a video for that. I did post the recording, so let's continue for today. And we did check the subnet mask when an IPv4 is assigned to a device. The subnet mask is used to determine the network in which the device belongs to. So we did that. We also check the default subnet mask. We say for class A, the default is /8 or 255.255.0.0.0. For class B, it's /16 or 255.255.0.0. So we did that. Why /8? Because we have 8 ones. For class A, the first block is for the network. It doesn't change. So if you put all ones, that's why you say /8. If you convert this one in decimal, you will see 255.0.0.0. Now, we're going to do for class C, by default, the first 3 blocks are for the network. It doesn't change. And we can change the host, like .1, .2, .3. So because the 3 blocks are for the network, we put all ones, then it will /24, or we have 24 ones. So by default, a class C, this is the default subnet mask. Today, we're going to do subnetting. It means if you see the default subnet mask that is /24, if you have a IP and you don't see the default, it means, so let me put something like that. You have a big shape. Yeah. Oh, no. Shape outline. Fill. Yeah. Shape outline. Okay. So you have one big bedroom here. Where is add text? Yes. One big bedroom. It means I have /24 or 255.255. I'm going to change the color for you. I put this color. So it means if I have a default subnet mask /24, I have only one big bedroom. It means all the PCs, all the IPs will belong to one place, one network. If you change to /25 or anything different from 24, it means that one big bedroom has been divided in smaller rooms. So if you see a IPv/24, it means it will default. All IPs will belong to one network. But if you change /25 or /26 for a class C or /27 or anything different from /24, it means that one big bedroom has been divided in smaller rooms. Now the question is, question 1. How many smaller rooms now I have? Smaller rooms I now have. I have now. Sorry for my English sometimes. How many smaller rooms I have now? After that, question number 2. So let's say before I can put 10 people here, and let's say 2 people. Now I have smaller rooms. I can put more people. So how many people I can put in one smaller, or in each smaller room? That's all. If you understand that, you understood, let's say, half of that CCNA stuff. It's what we're going to do now. So if you see /24 or 255, it means that all these IP with that subnet mask belong to the same one bedroom /24. We default. That's why we say the default. If you see a IP and it's different from the default, it means it's no longer one big bedroom. It's different rooms. Now that's subnet mask will identify, is that IP belonging to room 1, room 2, room 3, or room 4? See? It's what we're going to do now. So I'm going to show you an example. I'm going to show you an example. So let's say you have this one. I'm going to copy. Oh, who is coming in so late? Yes, she told me that she was working till late. Oh, sorry. Yes. Okay. So we're going to do an example, very simple. And this one, we're going to do a lot on Saturday when we meet. The first time it seems strange, but the more you do, the more. So Miss Mwalwa, welcome. No worries, on Saturday when we meet, I'll try to make some summaries for you and how to help you, because you finish late. You work till late, so I'll try to help you. So no worries, just check for now. Just check the recordings and I'll explain to you. So guys, this is an example of IP address 192.168.10.12/25. If you see /25, does it mean that this IP belongs to one big bedroom?
Yes.
Who say yes?
No, 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 no.
No.
No, it's divided.
Yes.
No, it
If you
doesn't
see,
belong to one room.
So, sorry, Mr. Mark.
Yes.
One big bedroom is /25.
Sorry?
no,
Thomas, please, can you
One bedroom is 24 for one.
Guys, I did show you here.
Oh, it's
One
24.
big bedroom is
Mr.
24.
Mike, Sorry, I thought it was 25. Yeah,
Okay,
I didn't see properly.
okay, I
Yeah.
forgive you. Yes.
Thank you.
Okay, so if you see slash 25 for class C, it's no longer one big bedroom. It means that one big bedroom has been divided in smaller rooms. Pictures, no, shapes, yeah. In smaller rooms, like here. Oh, no, in smaller rooms. Is it? Okay, let me make a, okay, smaller, it can be something like that, or you see, but design, no, insert, shapes, this, yeah. So you see here, that big bedroom has been divided in 4 smaller rooms, you see. So if you don't see slash 24, it means that one big bedroom has been divided. But now the question is, in how many smaller bedrooms? It's what we're going to see now. Okay, let me reply to Mola. No worries. I will help you on Saturday. On Sun- Mm. You see, so now what we are doing, if you see slash 24, it means it's no longer one big bedroom, but that big bedroom has been divided in smaller rooms. So in which network or in which room or in which smaller room that IP belongs to? So let's do that. So when you have an IP like that, first thing first, the guidance, extremely important. Step 1, identify the class. Which class is here?
It's class C.
Very good. It's a class C. Now, step number 2, identify the default subnet mask for class C. It's /24, the default one. You see. Now, because it's /25, it means this is our 24. Now we say 25. It means we have our 24 and we added one more to become 25. That extra one, it has been borrowed from the host. So step number 3, find the bit borrowed. So you do 25 minus the 24, you see, then it's 1. It means I borrowed one extra from the host. If you borrow one from the host, at step number 4, identify how many networks you have, how many smaller rooms after you borrowed. You see, now there is a formula. We say 2 to the power of bit borrowed. This is the formula to find how many smaller rooms I have now. 2 to the power of bit borrowed. So you see 2 to the power of, I borrowed only 1. So 2 to the power of 1 equal to, if you don't know, you take your calculator, go to calculator, you do 2, the x and y on top, it means 2 to the power, you see, 2 to the power of 1. I borrowed only 1 bit, 1 extra bit. 2 to the power of 1 equal to. It means now I have 2 smaller networks or 2 smaller rooms. I'm going to draw it again. This guy, I take it, copy, and I'm going to put it here. Put it here, put it smaller. Anything inside, I remove. Now I do what? I take design or insert, shape. I'm going to take something like that. You see, I have now 2, 2. I can go down, make it bigger, you see. So previously I had only one big bedroom. Now I have two smaller rooms. So this one, fill, I put, oh, no, not this one. This one. Yeah, I can say so. Yeah. So you see, so if you don't have a slash, if you have slash 24, it's only one big bedroom. Now, if you increase it, like here, slash 25, it means it has been now divided into smaller rooms. How to find that, how many smaller rooms I have? You do 2 to the power of bit borrowed. So here we say slash 25. So you do 25 minus the default, that is 24. It's 1. I borrowed 1 here. Then to identify how many networks or how many smaller rooms now, you do 2 to the power of bit borrowed. 2 to the power of 1 is 2 smaller bedrooms. This is something important in IT. No worries, the first time it's frustrating, but the more we do, that's why I wanted to do 11 and 12, so that when we meet Saturday, we'll do some again. So before we continue, I want to help you with a table. But let me see. Yeah, a table. Yes, I'm going to show you, and I'm going to send you that table. It will help you a lot. Here, I'm going to say bit borrowed. Here, I'm going to say subnet mask. Subnet mask. So bit borrowed. If I don't borrow anything, it means the subnet mask is slash 24 with default 1. And how many networks, you see. So if I don't borrow anything from a host, I have a default 1, and I have only one network. Or you can also do the formula 2 to the power of bit borrowed. I didn't borrow anything, so 0 is 1. I have only one network. One network. Now, if I have one network, you should now know how many people you can put in these smaller rooms. How many hosts or people you can add. So if I have only one big network, how many people I can put? So let's do again something very simple. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 0, 0, 0, 0, 0. So these ones, it will represent the network. It never change according to the rules. Now, if I borrow, I need to borrow from the host. So you see here, I didn't borrow anything. But here, if I do this one, if I see this one, I did borrow 1 from the host. If I say this one, and this one will be slash, I had 24 ones before. If I borrow 1, now I have slash 25 or 25 ones. If I do the same thing, and I borrow now 2, 1, 2. So what will be the value of a slash?
26.
Very good, because I have my 24 ones and I did borrow 2 extras. Now it's 26. If I go further, now I say 1, 1, 1. It should be 8 and 1, 2, 3, 4, 5, 6, 7. So
27.
27. Okay. 0, 0, 0 borrowed. This is how it is. Borrowed. Now here I say 1 bit borrowed. 1 bit borrowed. Then it will be something like that. Let me remove that. You see, if it will be something like that, and I'm going to put it bigger. Yeah. 1 bit borrowed. If I say 2 bit borrowed, I put it here. 2 bit borrowed. If I borrow 2, it means here, you see, I add 2 extra. I take 2 extra from the now slash 26. Slash 26 means I have my normal 24 and I add it 2. Now, if I borrow 3 bits borrowed, it will be this one, you see. So what will be the value of a slash?
27.
Very good.
27.
27. 27. I'm going to borrow 4 bits. 4 bits borrowed. 4. I copy everything. I paste. You see, I borrow 4. I put 1 extra here. What will be the value of a slash?
28.
28. And you continue like that.
28.
Yeah, 28, you see. And we continue. And let us do one more. If I borrow 5, 5 bit borrowed. 5 bit borrowed. Now it will be, you see, I borrow 1, 1. No. Here. 1, 1. We go to 14. Yeah. I borrowed 5 extra. So it will be my 24 plus 5 is how much? 29. You see. So this is how we say bit borrowed. This one will help you clean, neat, and nice. So bit borrowed 0. So I have my slash 24, my 24 ones. If I borrow 1 bit, you see now I borrow 1 extra, it will be slash 25. See, slash 25. If I borrow 2, and we said if you borrow 2, we have slash 26. And you continue. 26, you see. If I 3, it will be slash 27. You see. If it's 4, it will be slash 28. If it's 5, it will be slash 29. You see. If it's 6, it will be slash what? 30. You see. 24, 25,
30.
26, 27, 30. You see. So these two, now you know, bit borrowed and subnet mask. Now we need to find, if I borrow, to find how many networks, you do what? 2 to the power of bit borrowed. Borrowed. I'm going to put in small, sorry, 2 to the power of bit borrowed. So here I did borrow 1. So 2 to the power of 1. So you took your calculator, you see, you clear everything. 2, you go to X and Y is also on top. To the power of 1 is 2. You see, it means I have 2 smaller networks or smaller rooms. If I borrow 2 bits, the formula says 2 to the power of bit borrowed. So 2 to the power of 2. I clear? So to the power of bit borrowed, I did borrow 2. Now I have 4 smaller rooms. If I borrow 2 bits, I have 4 smaller rooms or 4 smaller networks.
Sorry, Mr. Max.
Yes?
Sorry, Mr. Max. I don't see the calculation you are doing now.
No, I said, no, look here. I said 2 to the power of bit borrowed. So if you borrow 2, you do 2.
No, I don't see any. I just see the screen where you write one borrow what we did
Yes,
earlier.
yes.
But what you are
Yes,
doing now, I don't see the.
no, it's what I'm explaining. Here there is nothing like here.
Okay.
So here you see, that's what I
Mhm.
wrote here. You see this one. If I borrow 3 bits, the formula say 2 to the power of bit borrowed. So if I borrow 3, I take my calculator, 2 to the power of 3 bits borrowed. 2 to the power of 3, I
Yeah.
have now
Oh,
8.
okay.
I have 8 bits, 8 smaller networks. So you see, we have 1. You see, 1 times.
Oh, Mr. Max.
Yes.
So if I understand, when you say 2 to the power of bit borrowed, it means 2, you edit, you make sum. It's like that.
No,
So
no.
you take 2
Yeah,
plus.
No, not plus.
So you make plus or minus.
No. No. So now let's do a bit of grade 12 mathematics. Huh? So if you say,
okay.
It's
yeah, 2 times 2 times 2, for example. So this one is
Yeah. Oh, yeah.
so this one is so you see now. So this one is 2 times 2. So 3 times 2. You see, for example, 3 times 2, so 1
I get
times
it.
2, yeah, something. But if it's the power, for example, if I say 2 to the power of 2, it means 2 times 2. If I say 2 to the power, but a very good question, 2 to the power of 3, it what? It will be
3 times.
yeah, exactly. You see.
Yeah, 2, 2, 2, 2. Yeah,
Yeah.
I get it.
If I say 2 to the power of 4 to the power of 4, that's a very good question because it helps answer anyone else. 4 times 2 times 2 times 2 times 2. You see. Okay. So 2 to the power of 2, 2 times 2 is 4. If you take your calculator, you'll see it will be 4. That's why here, you see, if you borrow 2 bits, 2 to the power of 2, it will be 4 smaller networks. So if you see an example, if you see /26, it means I did borrow 2 extra. So you see, I borrowed 2 extra bits. Now, if they ask you how many smaller networks, you do 2 to the power of bit borrowed, it will be 4 smaller networks. If you see an example, /28, I'm going to give you an example now. If I say 192.168. Mireille, are you still there? You're quiet. If I say /28, so this IP address, it belongs to a network that has been divided in how many smaller network?
4.
4.
Sorry?
4.
4
Oh.
smaller network.
Yeah.
Why?
Because they take
3.
the
No, it's
3.
not
no,
three.
Hey guys,
the default the default
Mr.
24,
Mas,
then edit
can
2.
you show us the
yeah,
the
here,
table?
yeah.
Yeah, it's 4. You said it be 4 to
No. 4.
It's
yeah.
4.
4.
It's gonna be not 4.
4-bit borrow
It's
4.
it's 4-bit board.
It's 4.
So guys,
It's 2. Mr. Mas,
no, guys,
I
wait,
don't know how to put it.
No, guys, just wait, just wait. Yeah, just
It's
wait. My
It's
question
16.
is,
2.
It's
It's gonna be
16.
2 4 times.
yeah, 2 4 times. Yes,
Yeah.
2 times 2
2
times 2
times 2
times 2 is
times
how
2.
much?
It's 4 8 60.
Yeah, okay.
16.
Else you can take your calculator. 2 to a power of 4 is 16.
Yeah.
Congratulations for the lady who says so. 16
Yeah.
smaller networks or 15 smaller
Right.
rooms.
Yeah.
How did you find that? If you see /28, it means we did borrow 4 extra.
Yeah.
We have our 24 plus 4 extra, it makes 28. It means we borrowed 4 bits, and we borrowed 4 bits. Now the formula says to find how many networks, 2 to the power of 4. So 2 to the power of 4, it means
2 to
2
the power
times
of
2 times 2 is 4 here. You take like calculator. Now we have 16 smaller networks.
Yeah.
Now if I say /27, how many smaller networks we have?
27. It's a 3-bit borrow. It's gonna
Yeah.
be 2
Yeah.
the power of 3. It's
2
gonna
to the power
be
of 3, yes.
4
Yeah, it will be
8.
8.
Very good. You see. 8 smaller networks. You see.
Yeah.
Very good. See. So it's what we are doing here. If I borrow 3 bits, it's /27, I borrow 3 bits, 3-bit borrowed. Now you do your formula. 2 to the power of bit borrowed, 2 to the power of 3 is 8. Now here you see 1 times 2, it's 2. 2 times 2, 8. 4. 2 times 4, 8. 2 times 16 and 32. It means even if you do 2 to the power of 5, here I clear everything. 2 to if I borrow 5 bits, 2 to the power of 5 is 32. You see, and here will be 64. And to memorize, if you want to memorize, 1 times 2 times 2, or you do your formula here. See? That's great. We are getting there. So we understand bit borrowed. We understand subnet mask, how many ones we have after we borrow, with slash. So now you guys, you should be able to know the decimal of these guys. So you see, if you convert everything, so anytime you see 11111, it's 255, 255. 255, if you convert in decimal, 255. Now this one, You can see that it falls if you do your table. So who remember the table? Insert table. You always start with 128, 64, 32, 16. This one is network engineering. We can tell you, okay, you know what, Miss B or Miss Grace or Mwala, we're going to create, you're going to open, the business is going well, we're going to open 3 extra offices. Your IT engineer will pay you for that. Make sure everyone has IP addresses. It's what we are busy doing. So here, I'm going to remove this too. Okay. So if you see now this one, you need to convert in decimal. It's something we did. You put 1 here, you put 0, 0, 0, 0, and you do a conversion. 0 times 0 is 0, is 0, 0, 0. 1 times 128 is 128. You see here, the value will be 128. The slash 25, if you convert in decimal, it will be something like that. The same thing, if it's 11 or 1, 1, you put here, everything is 0, 0 here. 1 times 28, 1, see, now you do 128 plus 64. We have time to do that many times, so no worries. Today, I'm just telling you, plus 64, 192. See? So here is 255.255.255. What? 192. You see. If it's slash 27, and we take all these 3, 1, 1, 1, 1 here, you put them here, like that.
224.
Yeah, so 128 plus 64 plus 32, plus 32, 224.
234.
Yeah. And you continue doing the same thing. We are almost there. We are halfway. We are almost there. Now, how many hosts per smaller room? Per smaller room. Per smaller room. Per smaller room. Because now here, for example, we have 4 smaller rooms. If you borrow 2 bit, it's slash 26. Now we have 4 smaller rooms or 4 smaller networks. Now per room, how many people I can put in each room? It's what we're going to do. We also have a formula here, very simple. 2 to the power of 2 to the power of remaining remaining bits minus 2. This is the formula. Remaining. So this training we are doing all over the world, we are doing that with the same thing, with same content. That's why when you have your CCNA, you can work anywhere in this world. 2 to the power of remaining bit. So let's say I did borrowed 2 bits. I did borrow 2 bits here. If I borrow 2 bits here from the host, how many bits remaining?
Two.
4.
Bijou, how can I say 2?
4. It's 4.
It's 1 bit.
Guys, no, I'm angry against Bijou. I'm going to tell your husband, my dear brother, this is what you're. No, I'm going to tell him, I'm going to ask you for his number. I'm going to call him and tell him that.
This is a question, Mr. Max, please.
Yeah. So your wife started well. Now she's going to. Okay, so you see here, we say we borrow 2. So if I borrow 2, so 1, 2, 3, 4, 5, 6, sorry, 6, it should be 8 bits. 1, 2, 3,
Yeah.
4, 5, 6. It should be 8 bits. 1, 2,
Yeah.
3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Which one is fine? So normally I have 8 bits, but I borrowed 2. I borrowed 2. How many remaining?
6.
6.
6.
Good.
6.
Then you take your calculator. 2 to a power of 6 equal minus 2 equal. It means 62. If I borrow 2 bits, I can put 62 people per room. You see, now I borrow 2 bits. Sorry, it's not there. If I borrow 2 bits, the remaining will be 6, and I can put, if I borrow 2 bits, I have now 4 smaller rooms. And per each room, I can put 62 people there, or 62 pieces. If I borrow only 1 bit, I have now 2 smaller rooms. How many people I can put per room if I borrow 1? So if you borrow 1, so who can tell me?
It's gonna be 7.
Yeah, because if I borrow
7
1,
people.
the remaining is 7. You take your calculator, you clear everything. 2 to a power
2
of bit remaining
power
7
7.
equal minus 2 equal 126. It means I can put, if I borrow 1 bit, I can put 126 people, you see, in each room. If I borrow 3 bits, I will get 8 rooms, 8 smaller rooms. How many people I can put in each room? You tell me.
Sorry. 1, 2, 5. It's 5. 2 to the power of 5
Yeah, very good.
minus 2.
Good. See here, I borrow 3. The remaining is 5. 1, 2, 3, 4, 5. Then you clear your calculator. 2 to a power of bit remaining 5 equal minus 2 equals 30. It means if I borrow 3 bits, I will have now 8 smaller rooms, and per each room, I can put how many people there? 30 people,
30.
or 30 pieces. You see. And we do for this one. If I borrow 4, the remaining is 4.
4.
Then you clear 2 to a power of 4 minus 2. I have 14
So
pieces.
it's 4.
Why we do that? Your manager can say, okay, you know what? We have new people. We can accommodate, let's say, 20 people per office. Please create 2 new offices and put a maximum of 20 people. Or tell us how many offices you want. But me, what I want a minimum, a maximum of 20 people per office. Yeah, tell us how many offices. You see. So if your boss says, I want a maximum of 20. If you borrow 4 bits, the maximum of people you can put is 14. You see, so it's not good. If you borrow 3 bits, the maximum is 30. It means in that 30, 20 people can go there. Then you as a network engineer, you say, okay, if I borrow 3 bits, I will get 8 smaller offices. You see, now you divide your 8 offices, and you know that each office can accommodate a maximum of 30 people. So even if your boss says 20, it's fine, we can go in. But
Okay.
you see, if you borrow 4 bits, you'll get 16 smaller offices, but they can accommodate a maximum of 14. It's not good. Your manager says, I want 20. You see. So this calculation will help us in case our company grows, how to manage. Listen. We continue. If I borrow 5 bit, the remaining will be 3. If I borrow 5, the remaining will be 3. So you clear 2 to the power of bit remaining, 2 to the power of 3 equal
7,
minus
8,
2,
6.
6. Here, 6. You see? If I borrow 6 bit, the remaining will be 2.
Two.
I go 2 to the power of 2 bit remaining minus 2. I can only put 2 people. See? This is something, for the first time, it looks strange, but the more we're doing, especially on Saturday, yeah, the more. So we'll see, Saturday we need to do something, the following Saturday we need to do something, and the last Saturday we need to, so we have to plan these 3 days. People who are still struggling with host name, will have a team there. I'm going to help them for that. People who are fine with configuring host name or the password, will go in another group, group 2. So these guys will start doing, for example, these things until I'll help everyone. So after 3 Saturdays, normally everyone should be okay. So that's from June. Yeah, we are fine. And July again will be. You see, so this is something. So normally we are done for this.
Mr. Max,
Yes.
sorry, can you repeat just a little bit the last one you say? Bit borrowed 6, and the remaining, how it gives you 2. So if you borrow 6, it's gonna remain 2.
Yeah.
So the power of 2. So you're gonna make 2 times 2, or
Yes.
what
2
you
times
gonna
2.
do?
Yeah. 2 to the
But
power of
2
bit
times,
remaining. 2 to the power of 2 equal 4
4,
minus
okay.
2 equal 2. Always don't forget the minus 2. Minus 2.
There is a minus in the formula.
Yeah. There is a formula. Minus 2 here.
Okay. So you said if the client maybe needs 20 hosts, so we must be in the range of 30.
Yeah. Because if you borrow, for example, 4 bit, you have 16 offices. But here, each office can support a maximum of 14 people. Maximum 14. But your boss says, I need 20 people per office. So you cannot use that. You cannot divide. You cannot get 16 offices. But if you borrow 3 bit, you'll get 8 offices, and each office can support 30 people. So at least it's fine. Yeah. So 20 people, they can fit in a class of 30. So know what is this one we're going to do many times. So this table,
Okay,
guys,
but
you should know how to do that.
you can send us on in the WhatsApp group.
Yeah. Yeah, I'll do that.
By
Now,
email, inshallah.
via email. Okay. Now, there is something else called here. If I borrow 1 bit, subnet mask is in, how many more? Okay, it's fine. Now there is something called magic number. Magic number. What is magic number? Let's go back to our first thing. Oh, I'm lost now. Okay, it's here. So if you see such example, you see /25, then you do your stuff. Now that you know your table, if you see /25, automatically you know that I did borrowed 1 bit. I have now 2 smaller networks. Now the magic number, if it asks you what is the IP of each network, then the magic number comes in. It means what? IPv4. So you can use the guidance. So you have 2 ways. You can either use the guidance or you go directly to your table. So now here, if you have such IP, you can do step by steps. Step 1, identify the class. It's a class C. Step number 2, identify the default subnet mask for class C is /24. Now find the bit borrowed. You do 25 minus 24 equal 1. And you put it nicely here, you see. Now step number 4, identify how many smaller networks now. So 2 to the power of bit borrowed, 2 to the power of 1. I have 2 smaller networks. Now we need to identify these 2 smaller networks. So always the first one will start with 0 by default, you see. So why we have these 3 blocks in black? Because for a class C, if you have a question, a class C, the first 3 blocks will never change. It will represent, let's say, the roots, the network side. So this one never changes. So you put these 3 there already. And because now I have 2 smaller networks, the first one will always start with 0. This is my very first network, or my very first room here. See? Now, how to find the second one? Because we say I have 2. How do I know it's 128? It's where the magic number comes in. So you take the bit borrowed here, you see, I did borrow here. How many one is here? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So you take this one, you see, and you do your table. It's a magic number. You do your table, and you put that number in the table. And you go left to right. You take the last one. So I only have 1 here. So this is my magic number. And you take your magic number and you put it here to find the second network. You see. So it's very simple to check magic numbers. It's what we're going to do that side. Copy. Today is today, and after today, I can say you are network engineers. You are network engineers. So magic numbers. So if it's /25, it means I borrowed 1 bit. This is. If I say now /26, I'd borrowed 2 now. So we take this 1100, it's here. What is it? So now what will be the magic number if I borrow 2 bit like this? We go left to right and we take the last one on the right. So 1, 2, this is the last one. Now the magic number will be 64. See? It means everything will be plus 64, plus 64, plus 64.
Yeah.
So, so for an example, wait. What is our IPv4? So if we take that, this guy, and we put it that side. For example, if I say /26, you see /26. If you did your table already with all your calculation before, /26 is here. It means we did borrow 2 bit. We have 4 smaller networks. How to identify these 4 smaller networks? To identify them, because it's class C, 1, 2, 3. This one will never change. You put it down here. Now, the very first network start with what? 0, always. The very first network. The second network will be this one plus the magic number 0 plus the magic number. Here the magic number is 64. It's no longer this guy. Because we say what? Left to right, and I take the last one at the right. You see? So the magic number will help us to identify all the networks that I have. See? So if the first network is 0 plus the magic number, the second one will be 0 plus 64. You see? The third network will be what? The same here. So 64 plus 64 plus the magic number. 128. See? To find the last one, we say again 128 plus the magic number. 128 plus 64. So 128 again plus 64. You see? 192. So the magic number is a number that will help us to identify all these networks that we have. You see, these are our 4 networks. Magic number. So if I borrow one, if I don't borrow anything, there is no magic number. So here will be 254. If I borrow 1, it will be, so you see the 1, that 1 falls in 128. So magic number will be 128 here. If I, sorry, not there. If I borrow 1 bit, it's 120. If I borrow 2 bit, the second one falls in 64. If I borrow 3 bits, it falls in 32. If I borrow 4 bits, it will fall in 64, in 16. If I borrow 5, it will fall in 8. If I borrow 6, it will fall in 4. So let's check for 6. If I borrow 6, see, I borrow 6. 1, 2, 3, 4, 5, 6. The magic number is what?
4.
4. Yeah. So guys, I'm very proud of you. You made it. Because in the whole CCNA we teach, it's only this part that messes up student mind. But if you understand this one, it's finished. You have 100%. I can say that your CCNA course is done already. You see. So the magic number is 4. If you borrow 5, the magic number is here. If you borrow 4, the magic number is here. If you borrow 3, the magic number. If you borrow 2, if you borrow 1 only. You see. So normally we are almost done. There is only one thing and we are done for today. So magic number is a number that will help us to identify all the networks. The first one will start with 0. After that, plus magic number, plus magic number, plus magic number, plus magic number. Now that we found all these 4, there is something called, so if I take the very first network, what is the first host? Oh, yeah. The first host I can assign, the last host. So this is the last part and we are done. And we broadcast BR. I'm going to teach you that now. It's very simple, clean, clear. Sorry, guys. This is the last part. So when you have such network, the very first IP address you can assign to a PC will be always the network plus 1. You see, this network, oh, See, this the network plus 1. See, it will very first IP you can assign to a PC or to a tenant. Now to find the broadcast, if in this network you want to send a message to everyone, we call the broadcast. How to find the broadcast address? You do the next network. You see the next network, the second network minus 1. 64 minus 1 is 63. You see. We'll do that again many times. So let's on Thursday, the first part, we do quick revision for IPv4. Then I teach you a bit of IPv6. IPv6, there is nothing too much, so we can finish that. Now, to find the last valid host you can assign to a PC, you do the broadcast minus 1. It will be 162. So remember how many hosts if I borrow, so here with /26 now, in your table, see /26, it means I did borrow 2 bits. If I borrow 2 bits, I have 2 to the power of 2, 4 smaller networks. And how many hosts per smaller room? I have 62 people, 62 PCs I can put in each room. So you see here, I have 4 rooms, the first room, second room, third room, fourth room, and per room I can put 62 people. So you see here, the very first one is 61. So if I have 10 PCs, the first one 10.1, 10.2, 10.3, 10.4, 10.5, I see, until the last one is 10.62. You see, it means really I have 62 people I can put in. See. Let us do the second one. And you'll send me, I'm going to send you, you must tell me for this one. So I'm going to copy, I paste. Always, if you have a network, I'm going to put in bold here. Yeah. Bold. So if you have a network, this one, doc64, always to find the first host, you do what? The network plus 1. So 64 plus 1 will be 65. To find the broadcast, you do the next network minus 1. 128. Sorry, 127. And to find the last, you do the broadcast minus 1. 126. You see. So check 1 minute, then you will tell me what I can put here. I remove my things. So check these 2, then you will tell me for the third one. Take your time and no rush.
The first one it's we must plus 1 FH.
Okay, so if you're in this network, the first IP address, the first valid IP address you can assign to a PC will be the network plus 1. So it will be 129.
And the second one, it will be minus 1, the LH.
Okay, let's say, so let us give the last host. So let's go to the broadcast.
It's an IP 191.
Minus
very good. You do it. So you do the
191.
next
191.
Very good. You do the next network minus 1. 191. Very good.
Yeah.
Now, when you know that, to find the last host, you do the broadcast minus 1.
Minus
190.
Very, very good. That's all. I can say your CCNA, you won it. This is the most difficult thing in CCNA, and you understood it, it's very good. So we are done for IPv4, guys. We are done. Don't go read what is in NetAcad. Focus on what we did here. I'm going to give you some exercises, especially on Saturday. And anyway, I'm going to send to give you two examples. Then you can. So now the question is, if you see that IP address, in which room it belongs to? You say 192.168.10.12. In which networks, in which room he belongs to, this tenant?
Public.
No. So you see that
No,
10.12. So you see it falls somewhere
the first
here.
host. The first
Yeah, I
host.
see. Very good. So
The first.
10.12, you see, 10.12
Yes,
is
yes.
somewhere here.
Yeah.
10.12 is between 10.1 and 10.162. So this guy belongs to this room, to this network. You see. Now, you can say this, or you can also say, or /26, if you convert in decimal, it's what? 255.255.55. Remember your table. If you do nicely, /26, you borrow 2 now. You see, it's in 192. You see, you just need to convert everything here in decimal. That's all. So this guy, you can say /26, or this is the normal 7net mask in. So if you use binary, it's /26, 26 ones. If you convert all of them in decimal, you'll find this. And because it's 10.12, 12 is between 1 and 62. So this IP belongs to this network. We are done for this chapter 11, the most difficult one.
Hi.
That's all. But I'm very happy that yeah, I'm going to send it via email. I'm going to send via email so that and you also have the recordings. All the recordings are in. If you go to the website, to YouTube, Learn Networking Academy. I think I did post the WhatsApp. You can go to YouTube / Learn Networking Academy. You see here, YouTube / Learn Networking Academy, one word. You come to playlist. You come to CCNA1.
Mr. Max,
And you'll see all the chapters here. CCNA1 chapter what? There is either other recording of chapter 11 that I did. Yes, question?
yeah, a question seems to be stupid question. In the table, when you write how many networks, so I want to know which networks in you can use another language beside network when you say how many networks. So what do you want to say?
Yes.
I don't know.
Yes. Okay, you're right. Smaller, you're right. How many smaller networks or smaller rooms?
Yeah.
Yeah, you're right. Yeah. Because sometimes it can get confusing. How many smaller networks now? So if you borrow 1 bit, you'll get 2 smaller networks or 2 smaller rooms. Now, how many hosts per room or per smaller networks?
Okay, but I want to go deeper about my question. When you say network, smaller networks, oh, I don't get it. Is the range or
No, 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 not
the
the range.
devices?
I did no at the beginning. I remember I said if it's the default, it's one big bedroom. Now, if you go to slash, that is different from the default. It means that big bedroom you did divide it in smaller bedrooms. Now, how many smaller bedrooms? We did 2 to the power of bit borrowed to find the smaller bedrooms. It's what we did here. So if I borrow 1 bit, it will how many smaller networks? 2 to the power of 1, I'll get 2. If you borrow 3 bits, like slash 27, how many smaller network you have now? 2 to the power of 3, now you have 8 smaller. Okay, let's stop for now. If not, you will get confused. Take your time to digest. I'm going to upload, watch it again, then you'll be fine, no worries. So let us stop for today. Okay, I'm going to stop the recording. Then it's